Hey there, Hampshire Chemistry. Glad to have you all here today. In today's video, we're going to be continuing to build our understanding of the periodic table, specifically continuing to understand more about the electrons. So, today's goal of the video is that I can model and identify the valence electrons on an atom. Okay, so this term might seem a little new, right? We've talked about electrons, but valence electrons is a specific type. So what do those mean? Well, valence electrons are very simply electrons on the outermost energy level of an atom. So they are on the outer edges of the atom, furthest away from the nucleus. And we're going to be modeling those together here today. So let's take a look at our sheet. We're going to look at and drawing 8 atoms together. Okay, we're not going to do all of them here in this video, but we're going to start with an example like oxygen. Okay, we need to do a few things here. We are going to be using the Bohr model to represent our energy levels. We're going to use our arrows, kind of like our orbital diagrams. And lastly, we're going to be circling those valence electrons. So let's get into this. When we look at an example like oxygen, hey, we know that oxygen is going to have 8 protons. So that means it's going to have 8 electrons as part of its model. Okay, this is the total amount, not the valence. We'll see what the valence looks like here in a second. So I'm going to start with the nucleus of oxygen. I'm just going to go ahead and keep it simple and write I have an 8 plus charge here in the center. And then I'm going to start drawing the Bohr model for this guy. So since oxygen is in the second row on the periodic table, that tells me that it's going to have 1, 2 layers of electrons. These are each of the different energy levels. Remember that this first energy level here is made up of the 1s orbitals, right? That's like the one box on our orbital diagrams. Now the second energy level here, this is our 2s, but also our 2p orbitals. Okay? While these are both separate orbitals, right, we tend to draw them as separate boxes, something like this. Okay? They are very close in energy to each other, so we essentially assume that they are on that second level. So let's go ahead and start filling in some of those electrons. We should remember that each of our orbitals here, like our 1s orbital, can only hold 2 electrons. So I'm going to go ahead and draw an up arrow and a down arrow to represent the 2 electrons that are inside of our orbital diagram. So I've used 2 of my 8. I have 6 more to place. The 6 then are going to have to go around our around our second electron energy level. I'm going to go ahead and place them as if I was filling in one of these diagrams. So I'm going to do 4 electrons that are existing as separate arrows. Okay? Remember, because these electrons will do their best to not pair in order until they are forced to. Okay, notice here I have 1, 2, 3, 4, 5, 6 electrons used, so I have 2 left to go. Now I am forced to pair some of my electrons. I'm going to go ahead and put my 7th electron and my 8th electron on this atom. So I have all of my electrons labeled, and my step here is then to figure out who are my valence. Well, we said the valence were the ones on the outermost energy level. That's pretty simple. So our outermost is the second level. So I've got 2 here, 2 here, 2 here, 1 there, and 1 there. So I have a total of 6 valence electrons in the oxygen. Okay? I will leave you guys to try out the rest of them, but I do want to kind of model what we do for the second part of this activity, because once you've made this model, we can understand a lot more about our atoms. On the second page of this sheet, we take a look at how these guys gain and lose electrons in the course of bonding. And this is going to lead into our discussions about understanding how atoms come together and how they form specific compounds. So, in order to understand this, we do need to make sure we see this important vocab up here, the octet rule. Okay? It talks about how atoms are most stable when all of their highest energy level are full. And that means for most atoms in the first few rows of the periodic table, they want 8 electrons in their outermost level. So we can look here at oxygen. We know that oxygen had 6 in its outermost level. There it is. And if it wants to get to 8, is it going to gain electrons or lose electrons? Okay, well, atoms are a lot like chemistry students. They're going to try and take the easiest method possible. So in this case, oxygen has the option of either gaining 2 more electrons to go up to 8, or if it loses all 6 of its outer electrons, then the inner level is also full. And I hope we can see here that gaining 2 is going to be a whole lot easier. So this oxygen will gain 2 electrons. And if I gain 2 electrons, that means I now have 2 extra negative charges. So I would have a charge on this oxygen of -2. And the way we tend to write that is I write the symbol O, and then an exponent here, I'll put 2 minus to represent the negative charge of this atom when it gains those 2 electrons. If I was losing 2 electrons, well, then I would have a positive charge for my atom, and that lets me build my understanding. And you guys are going to be taking a look at all 8 of these drawings. Remember, you're going to want to draw the models as we did here, being careful to make sure you're understanding the different levels and placing our electrons in the different places, and counting up those number of valence of electrons. Okay, look out for some patterns. Okay, that'll make this a whole lot easier going down the road. Okay, so try this out. Do your best to reach our goal of modeling those electrons, and we will continue building this understanding into our bonding and naming unit. Thank you guys so much, and enjoy the rest of your day.